Hello everyone, welcome back to OSCE Math. This is the third part of our 9 special integrals. Till now we have discussed the first 6 special integrals and today is the turn of last 3 special integrals. So here's the last 3 special integrals which we will be discussing today. Here we have to note that the function is not a fraction, it's just a square root x square plus a square root of x square minus a square, and a square root of a square minus x square. So let's get started with question 1. Evaluate integration of square root of 16 plus log of x whole square over x dx. Here it is clear that the derivative of log of x is 1 by x. So first we will assume this log of x to be t. So put log of x equals to t, and on differentiating we will have 1 by x dx equals to dt. Therefore integral I equals to integration of square root of that 16 can be written as 4 square plus log of x is t square and dx over x is dt. Now this is in the form of this first formula, that is integration of square root of x square plus a square. So using the formula we will have x over 2, that is t by 2 square root of x square plus a square by 2, that is 4 square by 2 log of x, that is t, plus of square root of x square, that is t square plus 4 square plus c. So simplifying and putting back the value of t, we will have log of x square root of log of x whole square plus 4 square is 16 plus 4 square is 16 and 16 over 2 is 8 log of x plus square root of log of x whole square plus 16 plus c. Question 2. Evaluate integration of cos x into square root of 4 minus sin square x. So here also the derivative of sin x is cos x. So at first we will assume this sin x to be t. So let us put sin x equals to t, and on differentiating we have cos x dx equals to dt. Then my integral becomes integration of square root of 4 is 2 square minus sin x is t square and cos x into dx is dt. Now this is in the form of this third formula, that is square root of a square minus x square. So following the formula we have t by 2 square root of a square minus x square, that is 2 square minus t square plus a square by 2 sine inverse of t by 2 plus c. Putting back the value of t, we have sin x over 2 square root of 2 square is 4 minus t is sine, so sine square x, plus here it will be 2 sine inverse of sine x by 2 plus c. Question 3. Evaluate integration of square root of 2x square plus 3x plus 4. So this is in the form of a quadratic. So the rule is same. We will try to express this quadratic equation into the sum of or difference of a perfect squares. Before that, there is the coefficient of x square is 2. So taking out this 2 outside the integration, so we will have square root of 2, which will be taken out from the square root. Then we will have x square plus 3 by 2x plus 2 dx. And here the coefficient of x is 3 by 2. So multiplying 3 by 2 with 1 by 2, we have 3 over 4. So we will add and subtract the square of 3 by 4. this equals to square root of 2 integration of square root of x square plus 3 by 2x adding 3 by 4 whole square and subtracting 3 by 4 whole square plus 2 dx equals to square root of integration of this everything is x plus 3 by 4 whole square minus, and simplifying these two terms we will have plus 23 by 16 equals to square root of 2 integration of x plus 3 by 4 whole square plus writing this in the square, so we can write square root of 23 by 4 whole square. This is in the form of first formula, that is square root of x square plus a square, and since this is a linear polynomial we can directly apply the formula. So it equals to square root of 2 into x by 2, that is x plus 3 by 4 by 2 square root of x square, that is x plus 3 by 4 whole square plus a square means square root of 23 by 4 whole square plus a square by 2, that is square root of 23 by 4 square by 2 log of x plus, that is x plus 3 by 4 plus square root of same thing, that is x plus 3 by 4 whole square plus square root of 23 by 4 whole square plus c. The formula is a little longer, but as you practice this sum using these formulas, then it will be much easier to remember. Now let us simplify the whole thing. Equals to square root of 2 into, here if I simplify then this will be 4x plus 3 by 8 square root of, and if I simplify this expression under the square root we will get x square plus 3 by 2 x plus 2. We will not get the original function as in the question, because in the second step we had taken out square root of 2 as common. We will get back this expression, that is x square plus 3 by 2x plus 2. So here we have, if you simplify then it will be x square plus 3 by 2x plus 2 plus 23 by 4 square 16 into 2 is 32 log of x plus 3 by 4 plus this will also be x square plus 3 by 2x plus 2 plus c. Now if I open the bracket with this square root of 2, then this square root of 2 then and square root of this expression will give you the original function. So here it will be 4x plus 3 by 8 into the original function was 2x square plus 3x plus 4 plus 23 root 2 by 32. Don't forget to multiply here also. Log of x plus 3 by 4 plus square root of x square plus 3 by 2x plus 2 plus constant of integration. Question 4. Integrate x minus 3 into square root of x square plus 3x minus 18 dx. Now this is in the form of linear into square root of quadratic. So here also we will try to split this integral into two parts by assuming this linear equals to a into derivative of this quadratic plus b. So we will first assume this x plus 3, that is putting x minus 3 equals to a into the derivative of the quadratic inside the square root, that is x square plus 3x minus 18 plus b. This implies x minus 3 equals to a into 2x plus 3 plus b implies x minus 3 equals to 2ax plus 3a plus b. Comparing the coefficients of x, we have 2a equals to 1. So a will be equal to 1 by 2. And the constant term 3a plus b is minus 3. 3a plus b is equal to minus 3. Putting the value of a and simplifying, we get b equals to minus 9 by 2. Now let us put this value in this equation. So we will have x minus 3 equals to 1 by 2 into 2x plus 3 minus 9 by 2. Therefore, my integral I equals to integration of, now instead of x minus 3, we will write 1 by 2 into 2x plus 3 minus 9 by 2 and square root of x square plus 3x minus 18 dx. Now we will distribute this integral with these two terms. So equals to integration of half is constant to x plus 3 square root of x square plus 3x minus 18 dx minus 9 by 2 is constant, integration of x square plus 3x minus 18 dx. So the integral has been splitted into two parts. For the first part, we will assume the quadratic, that is x square plus 3x minus 18 to be t, and differentiating we have 2x plus 3 dx equals to dt. And for the second integral, we will make that quadratic into the sum or difference of a perfect squares. So this equals to 1 by 2, the first integral, that is square root of everything is t, and 2x plus 3 into dx is dt. And on the second integral, there is a square root of x square plus 3x. To make the perfect square, here we have to look the coefficient of x is 3, and multiplying this 3 with half, we will get 3 by 2. So adding 3 by 2 whole square and subtracting 3 by 2 whole square minus 18 dx equals to 1 by 2. Integration of t to the power half is t to the power 3 by 2 by 3 by 2 minus 9 by 2. Integration of this everything is, the first three terms is x plus 3 by 2 whole square, and on simplifying the last two terms, we will have 81 by 4 dx equals to, here 2 and 2 will get cancelled, so we will have 1 by 3 t to the power 3 by 2 minus 9 by 2, integration of square root of x plus 3 by 2 whole square minus 81 by 4 is 9 by 2 whole square dx. This second part of the integral is in the form of integration of square root of x square minus a square. So there we will be using the formula. So here putting back the value of t in the first term, then we will have x square plus 3x minus 18 to the power 3 by 2 minus 9 by 2. So using the formula x by 2, that is x plus 3 by 2 by 2 square root of x square minus a square minus a square by 2, that is 9 by 2 square by 2 log of x, that is x plus 3 by 2 plus square root of x plus 3 by 2 whole square plus 9 by 2 whole square plus c. So let us simplify this everything, then we will have 1 by 3 x square plus 3x minus 18 to the power 3 by 2 minus, and at the same time let us open the bracket with 9 by 2 also. Then you will have the final answer as 9 by 8 2x plus 3 into square root of, if you simplify this, then you will get x square plus 3x minus 18 minus 729 by 16 log of x plus 3 by 2 plus square root of x square plus 3x minus 18 plus c. Question 5. Evaluate integration of 6x plus 5 square root of 6 plus x minus 2x square dx. So here also we will put 6x plus 5 equals to a into the derivative of the quadratic inside is 1 minus 4x plus b. So this implies 6x plus 5 equals to minus 4ax plus a plus b. So comparing the coefficients, we will have minus 4a equals to 6, so which gives a equals to minus 3 by 2, and the constant term, that is a plus b, equals to 5, gives, and putting the value of a, we will get the value of b as 13 by 2. So therefore 6x plus 5 can be written as minus 3 by 2, 1 minus 4x plus 13 by 2. Therefore my integral I can be splitted into two parts, that would be minus 3 by 2 integration of 1 minus 4x square root of 6 plus x minus 2x square dx, and the second part will be plus 13 by 2 integration of 6 plus x minus 2x square dx. For the first part, let us put the quadratic, that is 6 plus x minus 2x square equals to t, which will gives us 1 minus 4x dx equals to dt. And for the second part of this integral, we will make them perfect squares. So I equals to minus 3 by 2 integration of root t dt plus 13 by 2 integration of, but first here if you notice the coefficient of x square is 2 and not 1, so we will take out square root of 2 outside, then we will have square root of 3 plus 1 by 2x minus x square dx, and here the coefficient of x is 1 by 2, so if I multiply 1 by 2 with 1 by 2, this gives 1 by 4, so we will add and subtract the square of 1 by 4. So here I equals to minus 3 by 2 integration of root t is t to the power 3 by 2 by 3 by 2 plus 13 root 2 by 2 integration of square root of 3 adding the square of 1 by 4 and subtracting the square of 1 by 4 plus 1 by 2x minus x square dx. So here 3 by 2 got cancelled, so I equals to minus, putting back the value of t, that is 6 plus x minus 2x square whole to the power 3 by 2 plus 13 root 2 by 2 integration of square root of, if I add these two terms, then we will have 49 by 16, and taking out minus common here, we will have 1 by 4 whole square minus 1 by 2x plus x square dx. So it equals to minus 6 plus x minus 2x square to the power 3 by 2 plus 13 root 2 by 2 integration of square root of 49 by 16 is 7 by 4 whole square minus this everything can be written as x minus 1 by 4 whole square dx. Now this is in the form of square root of a square minus x square. So using the formula for the second part, we will have x by 2, that is x minus 1 by 4 by 2 square root of a square minus x square plus a square by 2 sine inverse of x by a plus c equals to minus 6 plus x minus 2x square whole to the power 3 by 2 plus 13 root 2 by 2. Here if I simplify, then we will have 4x minus 1 by 8. Square root of this everything will be at first 3 plus half x minus x square. 3 plus half x minus x square plus here it will be 49 by 32 sine inverse of 4x minus 1 by 7 plus c. Now if I open this bracket and multiply this square root of 2 with this expression, then we will get the original function. So let us open the bracket there. Then we will have 13 by 16 4x minus 1 and multiplying square root of 2 with the square root of this expression gives 6 plus x minus 2x square plus 49 into 13 is 637 root 2 by 2 into 32 is 64 sine inverse of 4x minus 1 by 7 plus c. So with this 9 special integrals comes to an end. So you might get confused with the formulas. For that you have to practice the questions related to these formulas more and more. So in the next video we will be starting integration doing partial fractions. So till then keep practicing. Bye bye.